Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Nindi Silviana, NIM 1903 5094. I'm from Chemistry Education A, and now I want to present my learning media. It's material about equilibrium shift. Happy watching!
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Good morning, students. How are you? I hope you're fine. Welcome to my class. Today, we will discuss about equilibrium shift. Let me start our learning. This topic about equilibrium shift, that part of material chemistry subject for senior high school, grade 11, semester 1. So this is all the part of the topic we will discuss or homepage of this learning. For the first, let me introduce myself. I am student at Padang State University. My name is Nindi Silviana and student ID 19035094 and my class Chemistry Education A, Minor Chemistry, Faculty of Math and Science. And my lecturer, Mrs. Eka Yusmaita, Faculty of Math and Science, and course based learning media and IT. Okay, we're back to home. The next is competence. There is four competence for this learning. The first is basic competence. The basic competence for this learning is analyzing the factor that affect the shift in the direction of equilibrium and its application in industry. The second is indicator. The indicator of this learning describe the factor that affect the shift in the direction of equilibrium and analyze the effect of change in temperature, concentration, pressure, and volume on the shift in equilibrium. The third is subject material. The subject material for this learning, the factor that affect in the shift of equilibrium. And the last one, learning objective. The objective of this learning is student can explain the factor that affect the shift in the direction of equilibrium and can analyze the effect of the change in temperature, concentration, pressure, and volume of the shift in equilibrium. Okay, there is the competence. Okay, we will next do the main of this learning is material. Okay, for beginning our study, what do you think about the picture, student? So there is a plant in here and sunlight, oxygen, carbon dioxide, sugar, and water. What do you think? What it is? Yes, that's right. It is photosynthesis reaction. So the photosynthesis reaction have the equilibrium reaction. There is carbon dioxide plus um, water equals to uh, sugar plus O2. And the reaction equation is 6CO2 plus 6H2O equals to C6H 1206 plus 602. So we can conclude photosynthesis as an application of equilibrium reaction is in everyday life. So we must know in our everyday life there is the application of equilibrium reaction. Example of example is photosynthesis. Okay, the next is what do you think about the picture? Okay, I'm sure that you're not familiar with this picture because it is only in fabric. This is the manufacture of ammoniac and sulfuric acid. This is the manufacture of ammoniac and this is the manufacture of sulfuric acid. So, manufacture of ammoniac and sulfuric acid as the application of chemical equilibrium reaction in industry, specific in shift equilibrium. So the mm, manufacture of sulfuric acid has equilibrium reaction and also with manufacture of ammonia. Okay, about the shifting shifting equilibrium is based on the Le-Chatelier's principle. Le-Chatelier's principle states when an action is held in an equilibrium system, the system will react in such a way that the effect of the action is minimal. So the shifting equilibrium is based on Le-Chatelier principle. Okay, the next is the factor that affect the equilibrium shift. There is four factors that affect the equilibrium shift. The first is change in concentration. The second is change in volume or pressure, change in temperature, and the last one is effect of catalyst on equilibrium. Okay, the first factor is change in concentration. The principle of change in concentration is if the first is if in a homogeneous equilibrium system the concentration of one substance is enlarged, then the equilibrium will shift in the opposite direction of the substance. So if we have the equilibrium reaction that have reactant and product, so if we edit the concentration of reactant, so the equilibrium reaction will shift, equilibrium will shift to the product. The second is when a substance is diluted by adding water to the system, the equilibrium shift to the own direction of the substance. So the from the reaction equation, if we add dilute by adding water to the product example, so the equilibrium will shift to the product itself. Okay. The next factor is change volume and pressure. But first is change in volume. The principle is if the volume is reduced, the equilibrium will shift toward the number of reaction coefficient is small. Um, Example, if we have the reaction equation like this, uh, 3H2 plus N2 equals to 2NH3. If the volume is reduced, uh, this have the 3 plus 1 reaction coefficient and the right side have 2 reaction coefficient. So if the volume is reduced, the equilibrium will shift toward the number of reaction coefficient is small. So the equilibrium will shift to the right side that have 2 or small coefficient in this direction. The second is if the volume is increased, then the equilibrium will shift toward a large number of reaction coefficient. So it is the opposite of conversely from the first principle. The next is change in pressure. Change in uh, pressure. Pressure is opposite from the volume. Why do we say that? Because if we see the picture, if the pressure is increased, the volume is decreased. If the pressure is decreased, so the volume is increased. So the principle of pressure is opposite or conversely from the change in volume. Okay, the next is the third factor that affects the equilibrium shift, change in temperature. According to Van Hoff law, when the temperature equilibrium system is rise, the equilibrium direction will shift to a direction that requires heat toward an endothermic reaction. So we will if example is there is a reaction that have noun delta H. So we can know from the sign of the delta H. If the endothermic, the sign is positive, and when the temperature equilibrium system is lower, the equilibrium reaction will shift in a direction that free heat or toward the exothermic reaction that's signed by a negative sign. So the next is the last one factor that affect equilibrium shift, effect of catalyst on equilibrium. The function of the catalyst in an equilibrium reaction is to accelerate the achievement of equilibrium and not change the position of the equilibrium. The equilibrium constant Kc is fixed. This is because the catalyst accelerates the reaction to the right and to the left equally. So if we see from the picture, it is the graph that no catalyst. And this one is reaction with catalyst. So the catalyst function is to accelerate the achievement and but no change the position of equilibrium. Okay, to make sure you understand for this topic, let's we see the animation about this learning. This is the example of equilibrium reaction. So we call it um, sub A substance, B substance, C substance, D substance. So in the picture, pink one is A, blue one is B, and yellow one is C, and green one is D. So the equilibrium reaction is A plus B equals to C and D. So it is equal. But we focus on the factor that affect the shift in equilibrium. This have have animation, but more explanation. But the 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 animation before is more explanation in this video. Let's we Let me watch this video.
Asas Likata layer. If in an equilibrium an object is given, in this case is the ball, then the equilibrium will change. So it is not balanced, and the end will be one side. To reduce the impact of this object, the equilibrium must shift to form a new equilibrium. This is called the Lee-Catelayer principle. The Lee-Catelayer principle cites if an action is given in an equilibrium, the equilibrium must shift and form a new equilibrium. And what is meant in this case is the effect of concentration, volume, pressure, and temperature. Okay, the factor. Yes, the first is the effect of concentration. If an equilibrium, if the sum of A and B is added, then the number of reactant will increase. And to reduce it, so the equilibrium will not balance. And to reduce it, C and D are formed. So the equilibrium will shift to the right side. From the explanation before, likewise, if what is asked, what if C and D is added, what happened with equilibrium shift? The next is the effect of pressure and volume. When the pressure is increased, then the volume is decreased. Conversely, if the pressure is lower, the volume is increased. There is a reaction equation. 1 mole of A in gas. This reaction is only in gas. Plus 2 mole of B equals to C gas and 1 mole of D. From the reaction, if the pressure is increased, then the equilibrium will shift to the direction that has the smaller mole. Yes, we know that in the reactant have 3 mole and the product of 2 mole. So in direction, the equilibrium will shift to the product or to the right side. And when the pressure is increased, is lower, then the volume will be bigger and the space will also bigger. So that the equilibrium will shift to the left side where the number of mole is bigger. The next is the effect of temperature. The change in temperature involves an energy, and if in an equilibrium will be affected by an increase and decrease of temperature. If increase of temperature will need energy, and if decrease of temperature will release energy. There is exotherm reaction. 2 mole A and plus B equals to C and D, and have the delta H minus 75. It is mean release energy. And if the temperature is increased, the equilibrium will shift to the left side or to the endotherm direction, and vice versa. And we have the exotherm reaction. If the temperature is decreased, the equilibrium will shift to the right side. That have exotherm reaction. For the exotherm reaction, endotherm reaction, the sign of plus it means need energy. When the temperature is increased, the equilibrium will shift to the right side or the exotherm reaction. And when the temperature is decreased, the equilibrium will shift to the left side and to direction to the endotherm.
Okay. Okay, we will next to the evaluation section. We will find out that how much you understand from the my explanation before. So we will start it. The first question, the following factor that can shift the equilibrium except. So there is some choice. Temperature change, pressure change, collision, change in volume, change in concentration. So student, how, what do you think? What the answer? We have explanation before. There is four factor that can shift equilibrium. So what do you think? Yes, yes, C, collision. Hmm. The reason is that factor that can shift the equilibrium is temperature change, pressure change, change in volume, change in concentration, and catalyst. But the catalyst is not change the shift, um, not change the position. So the next question, when the volume is enlarged, then the equilibrium shift to the right. Yes. So we have some reaction in here. Um, from the reaction, when the volume is enlarged, then the equilibrium shift to the right. Yes. So we know that when the volume is enlarged, so the equilibrium will shift to the um, direction with that have a large reaction coefficient. So from the A in left side is 2 and the right side is 3. B left side is 4 and the right side is 2. In C right in is 2, left right is 2, left is 2. D left is 2 and the right side is 1. And the E, the left side is 2 and the right side is 2. So from the explanation, what do you think? What the answer? If you said it B, so it is wrong answer because it is the large the large reaction coefficient in the left side. So the answer is A. Okay, we move to the next question. The equilibrium reaction that shift to the right if the pressure is increased. Yes. So we know that the pressure is opposite from the volume. So from the sum reaction, what do you think? What the answer? If you say that C, so it is wrong because in the left side 1 and right side is 2. So the large is um, the right side. But the if the equilibrium reaction that shift to the right if the pressure increase. So when the pressure is increased, the reaction equilibrium reaction will shift to the reaction coefficient that's small. So the answer is D. Okay, that's the some evaluation. I hope you understand that material, and we will discuss the other problems. Okay, thank you. Thanks for your attention, and uh, we will meet the next meeting. So thanks for your attention. Assalamualaikum warahmatullahi wabarakatuh.